Question 9. A frustrum is made by removing a small cone from a large cone. The cones are mathematically similar. Okay, I'm just looking at the picture here and taking it on board. The large cone has a base radius of r and a height h, that's mentioned there. Given that the volume of the frustrum is 98/125ths of the volume of the large cone. Well, it's all very well looking at the volume of the frustrum as a ratio of the volume of the large cone or as a fraction of the volume of the large cone. But the frustrum and the large cone aren't similar, are they? It'd be much more pertinent to look at the volume of the cone that's being cut off and the volume of the large cone. You see, if the volume of the frustrum here, if that bit is 98/125ths, then the volume of that small cone on the top there must be the remainder, 27/125ths. So, if I were to think about the volume here, and let's take the large cone and the small cone, the one I've cut off, then I would multiply by 27/125ths there to go from volume of the large to volume of the small. So that means that if I was dealing with linear lengths, the scale factor would be the cube root, wouldn't it? So the cube root of 27 is 3, the cube root of 125 is 5. So if I was dealing with lengths, I'd be multiplying by 3/5, and if I was dealing with areas, I'd be multiplying by the square of that 9/25ths. Okay, now, let's just go back to the question. Find an expression in terms of h for the height of the frustrum. Well, I can find an expression in terms of h for the height of the small cone. The height of the large cone is h, so the height of the small cone is 3/5 of h. Okay, so this height here is 3/5 of h, which means that the height of the frustrum must be the remainder, 2/5 of h. Okay, so height of frustrum equals 2/5 of h. And that was seemingly quite a complicated question until we broke it down into scale factors.